Hey everyone, welcome back to Summarize Science. Today, let's talk about making robots a little less robotic and a little more human. Researchers are working on systems that allow robots to understand our body language so they know when and how to start a conversation naturally. The challenge is to create AI that can interpret subtle cues like posture, facial expressions, and gestures to determine the best time to engage. This is particularly important in service roles, where a robot needs to approach people in a way that feels helpful rather than intrusive. One approach involves training robots with data from real-world interactions. In a museum setting, a robot named Mira was placed to answer questions about exhibits. The robot recorded interactions, tracking visitors' movements and body language as they approached. The researchers developed an interaction initiation system, IIS, that analyzes video data to extract key features like body position and movement. This system uses machine learning models to predict future body poses and classify appropriate actions for the robot, such as waiting, speaking, or listening. The system figures out whether it's best for the robot to say hello or wait for the person to speak first. To teach the robot these skills, the researchers carefully annotated video data, labeling each instance with the appropriate action the robot should take. For example, if a person was approaching and seemed open to interaction, the instance might be labeled Speak. If the person appeared hesitant, it might be labeled Wait. A human pose forecasting model was created using a BlockRNN time series model. It used the last 10 instances of data to predict the next 5, allowing a lead time of half a second for the robot to react. This is relevant for the recognition of user statements and the reaction time of the robot, giving the robot enough time to prepare to listen. The timing classifier requires the extracted features of the recordings and uses the human pose forecasting model to classify suitable actions for the robot. To test how well the system worked, the researchers compared the robot's decisions with the actual interactions. The results showed that the IIS could predict the appropriate timing for conversation initiation with reasonable accuracy. While the system isn't perfect, it's a significant step forward. The weighted precision stands at 74%, with recall also at 74%, leading to an F1 score of 74%. Further improvements could be made by using more data, refining the pose recognition, and explicitly considering the user-to-robot distance. The data suggests that the approach could be beneficial in other scenarios with stationary robots, but may require new data sets with mobile robots. By fine-tuning these systems and collecting more data, robots can become more intuitive and engaging conversational partners. This means technology that feels less like a tool and more like a helpful assistant. Ultimately, these advancements pave the way for more natural and seamless human-robot interactions. Thanks for watching today's video. If you enjoyed this summary, don't forget to like and subscribe to Summarize Science for more insights into the latest scientific research.